used for telecommunication satellites for DVB broadcasting. The transponders are basically a bit wider than the signal itself. So you could have the possibility to slip in a small signal nearby. That would have been testable. I don't know if anyone managed to do that, but certainly an interesting thing to do and research. A very common way to be your own satellite broadcaster is amateur radio satellites. There are satellites that are really not commercial satellites. They were brought into orbit by community effort, radio amateurs, and they can be used absolutely without problems, sometimes even with very, very low hardware recommendations. For example, an amateur radio handheld transmitter sometimes even works. You just have to go outside if you know the satellite is above you and press the send button and talk into the air, and you'll have some nice communications. That really works. I've tried it before. Yeah, there are also some more advanced amateur radio communications. You'll find information on that too later. Okay, now on to the legal stuff. Well, the active mode is very often illegal. For example, in Germany that would be interference with commercial interest. That could be, for example, in case of slipping in broadcasting IP information into the DVB stream, as covered yesterday in a lecture. That could be, the German word would be Erschleichung von Dienstleistungen. That's also a thing that can be prosecuted. Well, I'll rather not do that. It could prove very expensive for you if they find out who did that. Well, abusing commercial satellites, that's what we covered in the active point mostly, is, well, it's misuse, and it's mostly not legal. It's often causing interference to the things that are already there, the normal transmissions. Well, the really best way, I have to admit, to stay legal if you want to actively play with satellites is amateur radio. Because if you own an amateur radio license, you really are allowed to do satellite communications with amateur radio satellites as much as you want, as much as you can. Well, so much for the legal part. And now on to the questions and answers section. We know this was really a short and quite quick walkthrough on that topic. It's a very complicated and big topic. We're happy to answer questions now and also later on, or by email. We can be reached easily. Okay, now questions, please.
Okay. How can I find out when a satellite is overhead so that I can talk to it or can listen to it? Is that what these Kepler elements are for?
Yeah, that's what Keplerian elements are for. There is software available for most platforms, Linux also. There are Java implementations of prediction software that you just have to put in the Keplerian elements. That's just 2 lines, mostly 2 lines of data. Sometimes the software even downloads it itself from the internet, and then it tells you, okay, this on the time based now, the satellite is there. Does that answer your question?
Yes, thanks.
Okay.
What are the chances and methods to get tracked when you're actively playing with the satellite?
Well, that's a very interesting question, I have to admit. That fully depends on what you do. If you play with low power and not easy to track frequencies, that might slip through easily, but there are really also technical ways to find out where you were broadcasting from. I'm not very familiar with that, but I know there are, for example, special satellites in orbit that can be used to track your position, but also ground stations that could, for example, receive spurious transmissions from your transmission setup.
Thanks.
I wonder if you could talk about Thuraya and the security of their communications. They say that it's comparable to GSM, which seems kind of funny. And a couple of other questions.
Well, okay. I've seen and used Thuraya phones, but I only can tell you what you all already said. It is using actually GSM SIM cards, like some other companies too, and it could be really interesting to research that topic. But the communication itself between the phone and the satellite is probably more or less safe.
What kind of hardware would you suggest for automated tracking so that you could do some sort of programmable sweep of the sky?
If you want to track not only the geostationary satellites, but satellites that are moving, you'll need an azimuth and elevation rotor. That means an antenna can be turned once around and also from 0 to 90 degrees in the angle. And you can either build it yourself, depends on the size and weight of the antenna. There are azimuth elevation rotors for radio amateur use. That might prove not that expensive, or you can buy commercial ones that would be priced around 1,500 euros, I think, but they are very heavy duty and very good. It's a company called Aegis, if I if I remember correctly.
And about Inmarsat, you talked about Generation A. What about their always-on data terminals, and what kind of cryptography are they using? Have you monitored them at all?
Well, I haven't been playing with Inmarsat myself. I've just read and talked to people about that, and it's just based on my findings, what I was talking to people that have researched Inmarsat.
Thanks.
The other question.
Okay.
You talked about the thing you used and you tried in experiments.
Yeah.
It was like telephone communication or voice communication. Yeah. What is about information communication? Is it able to do kind of data communication, for example, with these amateur satellites, which is free to use?
Yes, certainly. You can use amateur radio satellites for data communication. A very famous example for that is the International Space Station that is carrying some amateur radio payload. Mostly it is in a mode called APRS, that's Amateur Position Reporting System. You can broadcast your position. With that system, it is a baud rate of 1,200 baud, more or less. And the uplink is at 145.8 megahertz, and the downlink is on 70 centimeter band. That's somewhere around 430, 440 megahertz. I would have to look it up. There are also other satellites that carry mailboxes. You can use them to relay messages. This was, for example, used for relaying messages between America and Europe for some time. And a thing really to mention is this is no real big bandwidth you can expect. And another thing is you can't use it for purely private communications, and you can't use encryption in amateur radio. So it's not you can play with it and have private conversations between you and someone else encrypting the path. Amateur radio is a mode that is public by definition. Does that answer your question?
Not really. One thing more. Is it possible to make a TCP/IP connection over satellites, over these satellites?
Yes, but it will be very slow. As I pointed out, the data rate is about 1,200 baud, and it is possible to work IP on that.
Thanks.
Have you looked into combining your setup with software radio technology, or
with what technology?
Software radio technology for demodulating?
Software radio. Well, software radio. Well, yes, it can be used. For example, if you have an intermediate frequency that can be listened to by a software-defined radio. Most software-defined radios I have seen mostly cover only shortwave frequencies and also need further intermediate frequencies, of course. Well, you can use that, of course, and it will certainly work. For example, an interesting thing would be to use a software-defined radio to look at the before-mentioned C-band transponders on Arabsat. You could see all phone lines at once. Well, maybe not all, but at least a few of them. Further questions? Okay. Another question, yes?
What is known about denial of service attacks on satellites? Is there any case known to you where people were involved in trying to bring down commercial service for a certain period of time?
Yes. For example, the Iranian government is trying to jam TV satellite transmissions by sending jamming signals on that frequencies. It is possible to partly prevent that jamming by shielding the antenna entirely with a cage, just to leave an opening towards the satellite. That mostly helps with that. There also have been attempts to, just jam input on broadcast satellites. I've talked to someone he was a normal broadcaster, and they forgot to call the satellite company that they were actually going to send something now to their base, and they turned on the signal on that transponder, measured in, and after around 20 seconds or so, they had a real big jamming signal on their transponder, preventing any transmission. Well, satellite maintainers are watching all